Okay, question 2. Classify the relations as functions or not. Okay, letter A. Looking at this mapping diagram, I'm looking at the domain always and see if anything's kind of getting repeated with an extra output there. 2 is going to 20, 2 is going to 40. That cannot happen, so this is not a function. Letter B, it's kind of the same way written as B, C, and D are, a little bit different formatting, but I'm looking at the domain. I always start by looking at the domain, and in this case, the domain is always the x values, 3, -4, 2, 0, and 8.4. Because nothing is repeating that domain and not going to a different output, I know that this is going to be a function. Letter C, same deal. I start by looking at the domain. Is anything being repeated? Oh, I did just repeat something. Okay, -3 is going to 4, and -3 is also going to 0. That cannot happen, just like in our mapping diagram on example A. This is not a function. They put it into a table of values. If we took those ordered pairs and put them into each and ordered into a table, it's the exact same idea. Look at that domain. -2, -1, 0, 1, 2. Nothing is being repeated. So, whoops, that is a function. Letter E, right here in that domain I'm looking at. And I notice is 7 goes to 12, 7 goes to 16. 7 cannot go to 12 and 16, so this is not a function. Letter F, this is a mapping diagram again, but what I notice on the input, the domain, is that 1 goes to 4, 2 goes to 4, 3 goes to 4. That is cool. We can do that as long as 1 wasn't also, say, going to, say, a 5 there. They can all go to the same location, but I can't have a value in the domain going to then a different output. So this is going to be a function. Graphically, the way that this would work, if I was to, say, give you a coordinate grid and I put on there a horizontal line, this is what it looks like. And if I plotted these points at 1, 4, 1, 4, 2, 4,